Hello, everybody. Today we're going to cover driver troubleshooting and some things to talk about first. So first of all, driver versions and the associated manuals. Driver versions are independent from the product, meaning the runtime. Well, I guess it could be the runtime or the development. And what I mean by this is you can use newer driver versions with older runtimes and older drivers with newer runtimes. This may be helpful if you've had to validate drivers, things of that nature, need to test out problems, things of that nature, and some other things to understand. The driver PDF manuals are separate from the normal help, from the technical reference. Now, this is handy to understand that if you go looking for information for a particular driver, you're not going to find it in the technical reference. Some things that you might find in the driver manuals, how to set up the driver, error codes, things of that nature. So let's go quickly. How do you find a driver manual, a version, and if you want to find out if you have the latest version, you can contact your distributor or your software vendor. So let's go into the development environment. And if I go here under help, notice here's where we would get to the technical reference manual, but here's where we find communications drivers. Things like the AB CIP driver, which I'm going to show in a minute. Now, if I click on this list and I just start typing the name of the driver, I'm going to do the Modbus TCP, so MOT. That takes me right to it. Now, I can either double click on this or click on help, and that will open up the PDF. Now, mine happens to be off screen. If I take a look at this Modbus TCP communications driver manual. Most of the driver manuals are laid out in a similar order. Not all of them, but general information for the driver, configuring the device configuration, configuring the driver, specifically the driver worksheets. There's a troubleshooting section, and often there's a revision history at the very end of the manual. Now, what I want to do is I want to go take a look at configuring the driver worksheets here. And you're going to notice that there is in most drivers, again, not all drivers, you're going to have a main driver sheet and then you're going to have standard driver sheets. Well, the basic difference there is the main driver sheet, you put everything in there and it scans at a default rate of 600 milliseconds and it optimizes the blocks of data types and order so that it can optimize communications. Now, some things to also to note is that in the main driver sheet, you basically only have a disable field and 4 status fields, and everything else you put in line by line for the individual tag, the PLC that you're going to go to, and the IO address. Now, if you add standard driver sheets, the station address comes out of this and goes up into the header, and you get some more triggering fields because you get to specifically trigger when the standard driver sheets communicate, either read or write or both. One of the things that is really necessary to understand when you're setting up a driver is how to configure these station fields and the IO address field. Now I'm going to scroll down because the station field is not just an IP address. I'm going to scroll down here now specifically for each driver. This is a little bit different, so you need to take a look for each driver. In addition to the IP address for the Modbus TCP, I need a colon and a port number. I'll often see people mistakenly, instead of putting a colon here, they'll put another dot, thinking this is kind of an extension of the IP address. Well, it's actually a colon, the port number, which for Modbus TCP is typically 502, and then another colon, and then the PLC ID number. Now, for different drivers, there are different things that can go in the IO address field, and it's also good to understand how all of these are formatted. And if you scroll down, you'll see more information about the standard driver sheet, and then a little bit more about let me scroll down even a little bit further here, and you'll see how to configure the syntax for that IO address field. Now, some PLC drivers, or some drivers in general, I shouldn't say PLCs because we have other drivers as well. Some drivers need not only the station address, but they will also need some more information. Like in this case for the ABC IP driver, if you're going to a Micrologix, let's say 1100, you would put 1100 in front of the IP address So it looks something like this. So that's an often overlooked thing as well. And again, every driver is a little bit different, but really pay attention to the station field. And now I'm going to scroll down here to the IO address field, because it's not only the tag name, but potentially you need the data type in front of this as well, whether it be a string, a single integer, dint. So that is some other information that you need to know as well. Now you're going to see this in the PowerPoint, but I recommend that you really start slow. Start with data type, one tag, try to get that working before you fill out your whole worksheet, just to make sure that you understand how that is in fact communicating, because I'd hate to see anybody waste a whole bunch of time. Now, worksheets versus tag integration. As I mentioned, the worksheets, now let me add this driver in here before actually that's the help. Let me go ahead and add in the driver here. So I'm going to right click on drivers, add in the Modbus TCP driver in here. So that's now part of my project. Now, when you take a look at a driver, you could right click on the driver name and go to settings, and this will tell you the different information that you have setting wise. A lot of times you don't even need to touch this. It's going to be set up by defaults to work with the PLC or the device that you're going to talk to. Sometimes you have to get in there, but the main driver sheet is what's listed by default. And again, this is 600 millisecond scan rate, and you don't get a lot of flexibility to modify that. There are some ways to do that, but you really get these 4 status fields, and a lot of applications that I get to take a look at have no tags in these fields, and that means that they're not monitoring whether or not they have communications. So for example, if I put in here, I have a temperature tag on that main screen. I'm just going to add that tag in here. So let me double click on this field, add that temperature tag. I'm going to bring in a simulated PLC here. So let me tell it that it's 127.0.0.1. That's my local loopback, port 502, and node number 1. Now the first holding register in that is memory type 4, address 1. And I'm not going to get into the individuals of this because we're talking more about overall troubleshooting, but that's the first holding register in that PLC. For now, I'm not going to put any status, any tags in the status fields. I just want to get this going with this driver. So let me open up this simulator, and this is something we found online. It's we give them credit. It's not ours. We don't support it, sell it. This thing is simulating Modbus holding registers in this case, and I'm going to write and read to this first holding register. Let me right click on this and make sure that this is always on top. Now if I run this project, it should communicate with that. So this is the value that I had in there before, and there we go. It's reading from that value here. And some things to note. Let's go back into the PowerPoint here, make sure I'm on track. Worksheets versus tag integration. So the worksheets, as you notice, I have this main driver sheet. When you first install a driver, you get this main driver sheet. If you want to, you can insert standard driver sheets. Now the standard driver sheets are slightly different in the fact that you have the ability to trigger these things when you want them to read or write, and you could have basically all kinds of flexibility in there, but you still get those 4 status fields. Notice that the station field is up here. It's the same, basically the same idea of how you configure it, but a standard driver sheet can only communicate with that station at that given time. You can in both the standard driver sheet, and let me split screen these. I'm going to right click. So here's the standard driver sheet. And let's move this over here. And here's the standard driver sheet. Here's the main driver sheet. So again, I have these 4 status fields, and I have those 4 status fields in a standard driver sheet, but I also have those triggering fields. Now, what I'd like to point out is you can have multiple standard driver sheets in addition to your one main driver sheet for each driver, but you don't have to use either of them. You can disable or enable them either by triggering them or by this disable field. And that's important to understand. Now, let me run this project again and show what happens. I'm already running it here. Um, Show what happens when we lose communications. Let's say I clip the cable, disconnect the cable, or power down the PLC. Some interesting things happen right away. So I immediately get question marks in here. I shouldn't say immediately because it does do an amount of retry behind the scenes. And where that comes from is here under the project viewer, show question marks when the quality is not good. The word quality is important to understand. The driver has reported that the quality for that tag is not good, and it shows question marks. This is an option so that depending on the industry that you're in, you might want to see the last known value. Most industries don't want to see a bad value if it's not valid currently. So that's why the show question marks is checked by default. Now what I'm going to do here is I'm going to go down into this output window here real quick and right click settings and show field read, field write. I'm going to insert the date and the time. Now what's happening is it's showing me every time it tries to read. Now I'm going to pause this for a second. This is showing me that it's trying to read that address, which driver at that station address, at that IO address, that it has a connection error, and the date and the time down to the millisecond. So this is extremely handy to troubleshoot driver connections. That's a kind of a one thing that you can do if the development environment is on the same computer as the runtime. If it's not, you have several options. Number one, there is an executable that can be run on the actual runtime that does not need this output window. Now when you run that, that's called logwin. And one of the easiest ways to do this, it's not the only way, but one of the easiest ways to do this is simply go to the symbol library, go to buttons, find logwin, which is here. Now it doesn't have to be this button. You can actually modify this, change this, go in here and look at your script. But when you use this, it launches the logwin, which is essentially the output window, on the runtime. So let me go ahead and try to do this here. I didn't try to do this before I started recording. I probably should have. And click on logwin, and there we go. We're connected, and there's my errors. And you can set this up very similarly on how you want to pick and choose what you record or monitor there. So that's a very handy tool. Another option of this is if you are connected remotely, which you can do this through this remote management tool, you can launch logwin and even database spy remotely. So you can put in the IP address in here, the host name, and get to it remotely. There's even a new option to have this encrypted. So that's another way to get at this information as well. Another way to notice if you have bad quality is if I open up a tag in the database spy, the quality column will tell me if I have bad quality for that particular tag. Now this bad quality for that tag doesn't necessarily mean that you have communications problems. Bad quality will show up in a tag if you have, let's say, a divide by zero or some other problem that's maybe in some expression that the result is generating this tag has a problem. It will show bad quality in here as well. Something else to pay attention to is, let me open up the help document here. If we navigate in here to the tags, tag properties, there's a complete list of tag properties. And to get at those, basically you put a minus, greater than, and then this property name, one of which is quality. And you can see here that 0 through 63 is bad, 192 through 255 is good, and here's similar to what I mentioned before, division by zero can actually set that. So it's not necessarily a driver error, but it's some things to pay attention to. And if I come back in here and I apply that, let's say temperature minus, greater than quality, you'll see that this shows that tag with that property is good, but don't be fooled. That 0, if we go back to the help here, that 0 means that it's a bad, it has bad quality. So pay attention to that. Now, the reason I'm bringing up some of this, you know, 0 means bad quality, is because most people actually take a look at the manuals when we're talking about quality. Let's go back to Modbus TCP, and let me scroll down to the troubleshooting section here. Most drivers, not all, but most drivers, 0 means good communications, and a non-zero value could be positive or a negative value means that there's some type of problem. So let's go take a look at this again. Let me go back into my runtime here. Let me open up the simulator again. This will automatically start to communicate. I didn't have to kick that off in any way. And now we've got communications going. Let's go back into our driver configuration and set up very simply the read status. Now let's put, I'm just going to put a generic tag in there, let's call it read status. It can be anything. Sometimes I'll simulate this as RS in some training classes just because I don't like to type. And I'm going to make this an integer. An integer will hold positive and negative values. And now let's simply display that on the screen. Now I've got many different ways I can display this. I'm going to use a rectangle to display this. And I'm going to simply call it com status. And below here, I'll do read status inside of curly brackets, which will display that value. And if let's see, since I created that tag, I will probably have to shut down my project and restart it. So let's save everything here, just so that it recognizes that new read status tag. And if I bring this in here, you can see that it's still reading from the PLC. Communication status is 0. If I disconnect the PLC again, you should see that com status go to a non-zero value. In this case, it's 16. If we go back into the manual and I scroll down, 16 tells me it cannot connect. Some things to try, ping, telnet, some different things to try there. So if I go take a look at this, what I have displayed is com status 16, or if the driver is working, it shows com status is 0. Well, for most people, that doesn't mean a whole lot. So let me show you a quick trick on an easy way to show communication status in a little bit more meaningful manner. What I'm going to do is take advantage of the built-in scripting language, and you know what, let me just do this. Let me grab a new rectangle here, and so I don't confuse anybody. Let's inside of curly brackets, I'm going to build a built-in scripting command that says if. So it's if, open parenthesis, and then read status is equal to 0, comma, then display good communications, or communications good, and then close that quote, comma, else, which means if it's non-zero, what am I going to display? Well, I'll display at this point com error, and then I'll put a colon, a space, and I'll close the double quote. But then after that, I want to concatenate. So I'm going to put a space, a plus, and then I want to concatenate the tag, read status. And then I want to close the parenthesis, close the curly bracket. And if all goes well, if I have good communications, it'll display com good. If I have an error, it'll display com error, a colon, a space, and then the actual communications error. And you could go on to say, look this up in the manual, or even display the messages that you'd find in the manual if you wanted. You could take this to all kinds of, so there we go, communications good. And if I disable the PLC again, we should see this com error 16, and that could, call maintenance, things of that nature. So lots of different ways to handle that. So let's see here. I want to go back and take a look at the PowerPoint, make sure I'm covering everything, worksheets versus tag integration. If you're doing worksheets, now I did the standard driver sheet and the main driver sheet, talked a little bit about those. Another way that we can configure project to communicate is here under project communications, we can add tag integration. Now there are several PLCs, not all the PLCs, not all the drivers I should say, support tag integration, only these few. And if you're using that, essentially it creates a driver worksheet behind the scenes, but you don't have access to that read status, read and write complete field. I would say that you could take a look at this quality property for the tag. Another thing that you can actually do, if I go back into the tech ref and I scroll down to the bottom of these tag properties, there are some tag integration properties, specifically the COM URL, whether or not it's used. These can be extremely helpful in troubleshooting tag integration type drivers. Let's see. Some other things that I wanted to point out, the status fields, how to display, that's what I just did with the if, the quality property. Let's go to the next page here. The output window, I showed the output window and then the runtime and the remote versions of the log win. I didn't cover the protocol analyzer yet. So if you are very advanced and maybe you know what's happening behind the scenes with your protocol. This is kind of similar to Wireshark. And if I enable that, let me delete this and unpause this here. What you're going to actually see, if my project was running, is the bytes of the protocol happening behind the scenes. So in this case, if I pause this, this is actually Modbus protocol, the transmit and receive of Modbus protocol. So if you know the protocol down to that level, you can actually understand the bytes of what's going on. Something new in let's see, I think we introduced this in version 8.1 Service Pack 2. In the past, you used to have to select all in here. Now you can actually highlight and select individual items. So if the technical support group is asking you to do a capture of this, that might be very, very handy to do that. Let's go back to the PowerPoint here and make sure I'm covering. So I did. Let's talk a little bit about virtual read groups. When you set up the driver sheets and even tag integration, this happens. If you go down to your taskbar and take a look here, you're going to see sometimes some icons don't get refreshed and stick around, but if you move your mouse around, those will go away. If you find the driver here and you right click on it, you can see virtual read groups, and this will show you how it has blocked up or optimized the reading or writing and telling you what it's doing. So this is often a very handy tool to understand what's going on behind the scenes as well. So that was what system tray virtual read groups, question marks. We talked a bit about that. Other potential issues, especially if you're running on an Ethernet network, you need to be able to ping. You need to be often on the same subnet to be able to get to the device. Make sure you can ping. Is OPC running? One of the things that I have happen a lot is because I often do OPC setup. I've got Kepware running here in the background, and if I right click, I have stopped it just before I started this video, because if my OPC server, and it doesn't have to be Kepware, it could be any OPC server running in the background. If it's, in this case, for Modbus specifically, I was communicating Modbus to this server and it wouldn't communicate to my simulator, so I've had to stop this. Now that doesn't show any error codes because it's actually communicating to something, but it was kind of stagnant at 0, and that kind of, oh yeah, I forgot I have that simulator or the OPC server running in the background. If you're using an RS 232 45, if you've often hand built those cables, I can tell you after 30 years of experience that they're often built incorrectly. Looking at diagrams, is it the pin side or is it the cabling side? Is it soldered properly? Is the jumpers there? It's often a cabling issue. Um, Sometimes for certain drivers, you need extra libraries installed, DLLs, things of that nature. No, those are particularly come into play when you have drivers for hardware cards that are installed in the computer, things like DeviceNet, CAN, some other drivers where you might have like Profibus, ABB Total Flow, things of that nature. So you might need extra files installed. Is the PLC in run mode? Some will not communicate if it's in stop or in program mode. So pay attention to that. The station field, as I mentioned, could be a port number with a colon. You could need the family name in there, and that again comes into play with the IO address format. Does it have to have the data type? Is it dint, string, things of that nature? Just start simple and get a small number of tags working before you complete your whole project. So with that, I think I've given you some things that should be able to help you out, and thanks for paying attention. Have a great day.